Hi guys, Ms. Vaughn here again. This is for my pre-algebra class. I'm going to work through the homework problems that you have for section 2.3, the distributive property. So you should have done yesterday, or hopefully you've done it today, numbers 2 through 44 even. They start on page 57 and go through page 58. So let me go ahead and switch over to my whiteboard and we'll get started. Got my coffee ready to go. All right, share screen, and here's the whiteboard. Okay, well, we don't want red, do we? Let's go with blue. Number 2 through 44 are even. So let's start off with number 2. So number 2 gives us -5 times 3 plus -5 times 2 equals something times 3 plus 2. Hopefully you've guessed what that is. You're taking out your factor, your common factor in both of these, which is -5. So -5 times 3 plus -5 times 2 is equal to -5 times 3 plus 2. All right, number 4 says that -10x plus 2x equals what plus what times x? Well, hopefully you were able to see that there was a common factor in both of those. So when you take that factor out, which is x, you're left with -10 plus 2. So you can see how when you have a variable, this simplifies your answer significantly because then you're able to solve the -10 plus 2 and you're left with an answer of 8x. But that's for another day. Right now, we're just using our properties appropriately. All right, so numbers 6 through 10, we want to use the distributive property to find the value of each variable. So in number 6, we're given 6 times 3 plus 15 equals 6 times 3 plus 6 times z. Now, hopefully you can see the distributive property at work here, and you see that we have we've reintroduced our factor, I guess. We've distributed it. So you have 6 times 3, and then 6 times z, therefore z must equal 15. There's your answers. Okay, moving on, number 8. So number 8 says that -5 times 4 plus a equals -5 times 4 plus 5 times 12. Now, what is this? Okay, so we just distributed -5 into 4 and into 12, but our -5 turned into a +5. Now, what times what equals a positive? So -5 times -12 equals a +5 times 12. Remember, a negative times a negative must equal a positive. So in this case, your value A is a negative because that's the only way you can end up with a positive. So A equals -12. So that's why we've worked so hard on chapter 1 and learning how we add and multiply negative numbers so that when you see something like that, you can understand what it means, that for that to be a positive, it must mean you have a negative times a negative. Okay, so let's move on to number 10. We have 2 plus 13 times 17 equals 2 times 17 plus C times 17. So we have our 17 accounted for. We have our 2 accounted for. So therefore, our C must equal 13. Excuse me. Okay, so now let's start on our B exercises. So number 12 through 18 says use the distributive property to write an equivalent expression and then simplify if possible. So number 12, we have 5 times 3 plus 19. Okay, so this becomes 5 times 3, not 7, plus 5 times 19. Now we know if you do your multiplication in your head, right here, we can mentally calculate this. 5 times 10 is 50. 5 times 9 is 45. 50 plus 45 is 95. And then 5 times 3 is 15. So we're left with an answer of 110. That's our simplification. This is our distributive property. And then the 110 is our simplification. So you should have both of these answers. Sorry, guys, my nose is running away with my face, so keep sniffling. Okay, number 14, we have 6 plus 11 times 4. So again, use our distributive property. We have 6 times 4 plus 11 times 4. If you've memorized your multiplication tables, then you've got this. You've got 24 plus 44 equals 68. So first you have your distributive property where you have used that to write an equivalent expression. And then because we have all integers here, we can go ahead and solve it, simplifying it down to a 68. Okay, number 16 says 7 times D plus 5. So you can't add D plus 5. This is when the distributive property becomes really important. So you have 7D plus 7 times 5. This is your equivalent expression. Fix my D there. There we go. But then we can also simplify the 7 times 5, which gives us a 35. And this is our simplified expression. And the last one of this section, we have number 18, which is 4 plus n times 15. So again, write an equivalent expression. We have 4 times 15 plus 15n. Remember, always keep your integer or your constant in front of your variable. All right, and then 4 times 15. Well, if y'all are like me, you know how I like to use my clock for my 15 times. So we know that 4 15-minute sections is 60. But you can also do 4 times 10 is 40. And then 4 times 5 is 20. And 40 plus 20 is 60. So we have 60 plus 15n. So this is our equivalent expression. And this is our simplified expression. Okay. So for number 20 through 26, we are using the distributive property to compute the following products mentally. So number 20, again, this is practice using those big brains of yours. So we have 4 times 7 plus 4 times 3. So calculating this mentally, you know that 7 plus 3 is 10. So you can distribute this and it becomes 4 times 10. Well, that's easy, right? 40. Okay. So number 22. In number 22, we're given 6 times 24 plus 6 times 6. Well, you know in this case, that's also 24 plus 6 is 30. 6 times 30 is much easier to do mentally because you know that 6 times 3 is 18. And then you just throw that 0 on there. So your answer is 180. Much easier than trying to figure out 6 times 24, right? Okay. So number 24 tells us 9 times 53. So again, in this case, it's better to separate it out. You know that this is just 9 times 50 plus 9 times 3. Well, 9 times 50, again, you know 9 times 5 is 45. Throw that 0 in the end, gives you 450. And 9 times 3 is 27. 50 plus 27 is 77. So you're left with an answer of 477. If that was a struggle mentally, you need to practice. Pick any set of numbers like this and practice solving these mentally by using the distributive property. A lot of you, I've seen you do this in class. I know that you already separate these numbers out like this, but others do not. So this is a great opportunity to practice that process. Okay, so number 26, we have 3 times 40 plus 3 times 60. Now, those aren't terribly hard. We could figure that out, 3 times 4 and 3 times 6. But what's even easier is that this becomes 3 times 100. Well, surely you know what 3 times 100 is, right? 3 times 1 is 3, and then throw those 2 extra zeros on the end and you're done. Easy enough. All right, 28. Is this the same section that we're starting something new? Okay, these are the C exercises, so we're getting just a little bit more complicated. So in this case, what you're asked to do is identify the property used for each step in simplifying the following. And then if an arithmetic operation is performed, I want you to write that it was an arithmetic fact. So let's look at the first example and you'll see what I'm talking about. So we have 6 plus 3r plus 5 is equal to 3r plus 6 plus 5. Now in this case, what have we done? You have them in one order on one side, 6 plus 3r plus 5, and the other one is 3r plus 6 plus 5. So we've taken our constants and we've put them together, which helps us simplify this into like terms. So what we've done here, because we haven't changed the order of operation, is we've used the commutative property. Of addition. All right, and then it tells us 3r plus 11. And of course, this is our most simplified expression. But all they've done is they've done 6 plus 5. Well, that is an arithmetic fact. It is simply addition. So that's where you're going to put those arithmetic facts. Anytime you're adding, subtracting, multiplying, or dividing constants. Okay, so let's look at number 30. Number 30 says 2x plus 3y minus 4x plus 8 equals 2x minus 4x. I'm going to run out of room if I'm not careful here. Plus 3y plus 8. So again, we are using the commutative property of addition to put together like terms. And so that we can then turn around and simplify. So I'm just going to put it underneath here because I've run out of room. And remember, you need to be able to communicate the difference between an addition property and a multiplication property, particularly with commutative and associative because they exist for both, and identity. Okay, so then the next step is, I lost my place. We have, they've taken out the known, the constant factors with the x. Okay, so we're left with 2 minus 4x plus 3y plus 8. So what's this? Surely you recognize it by now. This is our distributive property. Okay. And then we are solving the parentheses. So 2 minus 4 is a negative 2x plus 3y plus 8. And all we've done is solve a subtraction. So this is an arithmetic fact. Let's see here. Get all my answers. There we go. Okay. That might be it. Nope, we've got one more. Number 32. Okay, so number 32 tells us that 5b plus 6 minus 2b equals 6 plus 5b minus 2b. Now we can see that we have not changed our order of operation. We have simply changed the location of our various terms. So this was the commutative property. Of addition. All right, and then we have combined like terms. So we're left with 6 plus 5b minus 2b. So this, we recognize they're in the same order. However, your order of operation has changed. So this is your associative property. Okay, so then we go ahead and take out our constants. So we're left with 5 minus 2 times b, which we now recognize as our distributive property. Now, the distributive property only applies to multiplication, so that's why we're not specifying. Because it's dealing to the 5 times b and the 2 times b here. So it's not really having anything to do with the addition or subtraction that goes on between those two like terms. All right, so then we go ahead and solve the 5 minus 2. We don't really need that, do we? 3b. So this is just an arithmetic fact. And then we use the commutative property to change the order of addition. Okay. All right, so let's do a little bit of cumulative review. So I'm going to skip down to number 36. Since we all need this. So we're asked to write the following numbers in scientific notation. This is a review from section 1.8 when we learned scientific notation. So we have 0, 1, 2, 3, 4, 4 zeros, and a 56. So remember, if you're changing something into scientific notation, your factor needs to be what? Needs to be between 1 and 10. So this becomes a 5.6. And so then our decimal point moves 1, 2, 3, 4, 5 spots. Now, this is a very small number. So your exponent must be negative. Remember, a negative exponent simply means a small number. I lost my count. 1, 2, 3, 4, 5. Yep. So 5.6 times 10 to the negative 5. All right, number 38. Now in 38 through 44, we need to name the property or definition illustrated by each of the following. So these are from our previous two sections here in chapter 2. So number 38 says that 5 plus 2 plus 3 is equal to 5 plus 2 plus 3. This one should be pretty easy for everybody. You can see that the integers are in the same order on each side, but we have changed our order of operation. So this is associative. Property of addition. Okay, number 40. Now 40, we did review a little bit, but I know this can be a little bit confusing to some of you. So I'm glad they put this in there. So what we need to do is we need to recognize that z minus y is equal to z plus a negative y. Now, y'all remember this when I was teaching you about adding like and unlike signs, that those rules only apply to addition. So if you have a number minus another number, then you just throw a plus sign in there and then put the second number as a negative. And this shows you that you're not adding like signs, you're adding unlike signs because that negative moves into that second integer. So this is by definition, the definition of subtraction. By definition, subtraction is simply adding a negative number. Now, number 42, we have that plus 0 equals x. We know this one, right? We're working with addition, so this means that any integer plus 0 equals that integer, so its identity is the same. This is the identity property of addition. Remember, the identity property of multiplication is very different because you multiply any number times 1, not 0, equals that number. All right, and number 44, we have 9 times 3 plus 7 equals 3 plus 7 times 9. And this is the commutative property of multiplication. Okay, and that is y'all's homework. So If any of those were completely confusing to you, despite the fact that we've gone through them, please, please, you must let me know so that we can work with them together, because this section is definitely one of the most important that you're going to be learning as we move forward into pre-algebra. Otherwise, y'all are good to go. Have a great weekend, and I will see you next week. Bye-bye.